Okay, this video is going to deal with the recipe for success and how to go about doing a problem on type 2 errors and how you break it down. Very first thing you need to do is write the null and alternative. Here's your definitions of alpha, beta, et cetera, the measurements of type 1 and type 2 error. Make sure you define the parameter in context. And when they ask you what type of error, you need to make sure you define the type of error. And if it's a type 2 error, the probability of accepting the null, given that it is false. So that's the definition, and you always must give that definition before you write it up. Then you need to put it in context of the problem. In this case, the probability of accepting the null, given that the null is false, and restate the alternative, and the alternative is true. Okay, so this is the template that you need to use when you're working it. Once you've done that, you need to explain the consequences of committing a type 2 error. And please make those in simplified language. And you may have to just kind of guess as to what they are, but you're going to have to use your brain to think about what could happen if I failed to reject a false null in this situation. Methods of decreasing beta. We have a list here. You can increase alpha. You can increase power, or you can increase the sample size. Once again, please cross through the decreases type 1 error. And at the very bottom, and I covered this in the previous video, I talked about p-value, so I'm not going to discuss it here, although we may approach it on the next page scenarios. All right. So this is a step-by-step on how to go about working these problems. And it's really key that you actually start off by defining the null, or writing the null, the alternative, and defining the parameter. So we're going back to the same music problem, but now we're looking at it from a type 2 error scenario. So a researcher wants to conduct a study to test whether listening to soothing music for 20 minutes helps to reduce diastolic blood pressure in patients with high blood pressure, compared to simply sitting quietly in a noise-free environment for 20 minutes. 100 patients with high blood pressure at a large medical clinic are available to participate in the study. The null hypothesis for the study is that there is no difference in the mean reduction of diastolic blood pressure. So whether I'm listening to music or whether I'm sitting in a quiet room, the drop is going to be the same. Here is saying the drop for listening to music is greater than the drop for not listening to music. Once again, the very first thing it says do on the recipe is write my null and alternative, and then I need to define it. The true population mean drop, the true diastolic miss drop for sitting in a room. Okay, so I defined it. Then part B, then it says, part A says, describe a type 2 error and its consequences in the context of the study. Even if they don't tell you the consequences, you still have to do it when it says describe a type 2 error. So then the last also discuss the context of the study, which is more serious, a type 1 or type 2. A type 2 error is mistakenly failing to reject the null when in fact it's false. That's just the definition. It lets people know what you're talking about. And chances are, if you have that and this part's a little bit off, you're likely to receive some credit. If you only write that, you get no credit. So in this case, we mistakenly believed that there was no difference in listening to music and sitting in a quiet room on lowering diastolic blood pressure, when in fact, listening to music was more effective. Consequent, as a result, the clinic would not provide an effective treatment listening to music for lowering diastolic blood pressure. In other words, they're not going to use a more effective treatment that's non-invasive for lowering blood pressure because they think it doesn't work. So what was worse, a type 1 or type 2? Probably for the clinic, a type 1 error is more serious because the clinic is wasting money on an ineffective treatment and telling patients they're improving when they are not. Patients, a type 2 error. is more serious because they are not receiving an effective treatment, the music, and will be forced to treat their condition with drugs or some other more invasive treatment. All right. Now you can argue about those, but those, if you ask me which one's worse, that's kind of my opinion. Your opinion might be slightly different, but be a little bit creative and tie it to the actual problem. Finally, a p-value of 0.247 is calculated. Explain the meaning of the p-value in a context and explain what type of error may have been committed. So the p-value is a probability of getting a test statistic as extreme or more extreme, given that the null is true. In this case, so basically I just defined it straight out, use the definition. In this case, there's a 24.7% chance we'd get a test statistic this extreme in favor of music having a greater reduction in diastolic blood pressure than sitting in a quiet room, when in fact the two treatments are equal in their effectiveness. So what type of error? Well, a p-value of 0.247 is greater than an alpha of 0.05. Thus, we would have failed to reject the null. If we fail to reject the null, the only type of error that we could have committed is a type 2, because fail to type 2. All right, so this concludes the videos on type 1 and type 2 error. Hopefully they are helpful. Please use the recipe cards as you write your problems up. Okay, thank you.